Okay, in this video we're going to make a simple Excel calculator for doing hypothesis testing on a single mean when we don't know the population standard deviation. So therefore we're going to be living on the student t-curve. And we're going to look at both situations where we're given raw data or we're just given the statistics of our sample. So we'll start with the one where we're given the statistics because we now already have everything we need, right? So every time we redo this, we just replace whatever's in the yellow, and then these three are going to repopulate with the correct answer each time. All we have to do is calculate this formula as our t statistic, and you can see it's just the mean minus the hypothesized, right, the null hypothesized value. So it's going to equal, and as always, when we're doing fractions, we have to put parentheses around the top for order of operations. So it's going to equal the mean minus the null value, close the parentheses, divide by, and then in parentheses, we're going to divide by the standard deviation divided by the square root of our sample size, and then close off that parentheses. Now, of course, since we're dividing by a fraction, we could have multiplied by the reciprocal and done all sorts of fancy algebra to make this formula a little nicer, but it's also easy just to do it as it sits, and again, just put in some parentheses to make sure that everything is done the way it's supposed to be done. Okay, the p-value, we've discussed about this in other videos, that the easiest thing to do is just always create a scenario where you're looking for the p-value associated with a positive test statistic. So you're just always going to take the absolute value of your test statistic, in this case my t-stat. And because we're taking the p-value associated with the positive one, we want the area above it, which means we always have to do 1 minus the actual function that Excel does, because it does the area below something. So it's going to equal 1 minus the t-distribution, and x, right? That's our t-stat that we're using, comma, degrees of freedom, remember, is just sample size minus 1, so it's going to be that minus 1, comma, cumulative is always true. And there's our p-value. And think about it, 2.7, so we're more than 2 standard deviations above the mean. That should be pretty small, and it's less than 1%, seems to be working. And then for a two-tailed test, it's always just that one times 2. And now that we've done that, we can copy this and paste it over here, and it's now trying to run these same calculations on these 3 cells above it. So like if we just copied these numbers and put them over here, and of course change that to 10, we would get the same answers. But we want this to be set up so it'll work when we're given data, so we just need this to calculate these things. So we're going to use the count function, and we're going to use it on the entire column of D. So that's going to count up all the numbers that are in that column. And then we're going to just do the same thing for the average. And again, if you click on the whole thing, it's smart enough to only take the average of the numbers. And lastly, we do the same thing for the standard deviation. And it's a sample, so we use the .s version. Click on D, so it gives us the whole D colon D thing. And there we have it. Right? And that's everything. So that's how we can do both a single mean when we're given the statistics and when we are given raw data. Thanks for watching.